Welcome everyone. Today we will learn checkpoint 12.1. Now this is our second lesson on chapter 12. Now based on this chart, you will notice that we have learned this trapezium rule last week. Now I hope you have done all the questions in 12.4. Now if you have any question for checkpoint 12.4, you can forward it to your respective teachers and they will explain it to you. Right? Now for today's lesson, we will learn numerical solution of equation. Means we are learning how to use these methods to find solution of equation approximately. Now we are going to learn graphical method. For this lesson, we are going to learn only graphical method, right? Now for iteration and Newton-Raphson, we will do it maybe in the next few weeks. Now by the end of this lesson, you should be able to locate the roots of an equation approximately by means of graphical methods. Means by drawing graphs, you should be able to locate the roots. And you should be able to use intermediate value theorem to show that an equation has a root between two consecutive integers. You have actually learned intermediate value theorem in semester 1. So it should not be a problem for you at this point. Now to find roots of an equation, now you have learned how to use factorization and also a formula to find a root. Now these two methods help you to find the roots exactly where they are. But for graphical method, we can only locate the roots approximately. Now let's go to graphical methods. Now if you are given an equation in this form and you are asked to find the roots using graphical methods, then you need to draw this graph. Now this is a quadratic graph, right? X squared. So you should get something like this. Now where are the roots? You can see there is a root here and there is a root here, right? Because this is fx equals 0. Fx equals 0 is here and here. That means there are two roots. There are two real roots. And the answer of the roots will be here. Your x value over here and your x value over here. That will be the location of the root. But I can choose to change it into this form. If I change the equation into this form, then I will have to draw two graphs. One graph which is x squared, and there is another graph which is a linear graph, 7 minus 3x. Now, this graph will be this, y equal x squared. And for this side, you will draw y equals 7 minus 3x, which is a straight line. So can you see there are 2 points of intersection here and here, which means there are 2 real roots for this equation. Now, what is the answer for the root? So your answer for the root will be here, the x value for this point, and the other root will be here, the x value for this point. So the location of the root will be here and here. Now you will see that these 2 answers, they are actually the same. It's just that the method, the graph that you draw, they are different, but the answers, they are actually the same, right? Now I choose this because it is easier, sometimes it's easier to draw x squared and a linear graph 7 minus 3x. Sometimes we change the form to simplify it, to make the sketching of the graph easier. Now, what about intermediate value theorem? As you can remember in SEM 1, now you have learned if there's a function y equal fx, and if, let's say, the shape of the graph is shown in the diagram here. Now, if I substitute x equals 2, if I substitute x equals 2 into the function, x equals 2, now you will get a negative value. All right. Now, if you substitute 3 into fx, you will get a positive value. Now, if the graph, you will see that the graph from 2 to 3, it moves from the negative area to a positive area, which means it passes through x-axis. So when the graph passes through x-axis, it shows there is a root between the 2 integers, right? This is what intermediate value theorem is about. Now, if there is no graph given to you, now without looking at the graph, we can use the intermediate value theorem to prove that this function has a root between 2 integers. Now, how to do it? First, we can substitute 2 into the function. Now, let's say you substitute 2 into the function, you get a negative value. And then you substitute 3 into the function, and let's say you get a positive value. Now, from here, it shows that there is a change of sign between 2 and 3. Now, when there is a change of sign, means the graph has passed through x-axis, which means there is a root between 2 and 3. So you make a conclusion which says like this: since there is a change of sign between f2 and f3, and fx is continuous, thus there is a root in the interval 2 and 3. Now let us look at the first example. By using graphical method, show that the equation x cubed minus 3x squared equal -6 has exactly one real root, and the root is between -2 and 3. Now there are two parts of the question. The first part, we must use graphical method to show that this equation has only one real root. Now if you choose this equation, now it's difficult to draw this graph if you choose this equation. If you use this equation to find the root, you have to draw this graph and this graph. Now this graph is difficult to draw, alright? So what do? I will not use this. I will change the form to this. We change it to this. Now you see that x cubed plus 6. I will use this -6 bring over here, and a -3x over there. So I need to draw this graph, x cubed plus 6, which is easier to draw, and another graph, quadratic graph 3x squared, right? So the first graph, now you can sketch the graph. It's quite easy. And then the second graph, y equal 3x squared, which is a quadratic graph. Get this, the blue color. Now the question shows that the equation has exactly one real root. So you look for the point of intersection. Now there is only one point of intersection here, right? So you make a conclusion. See the graphs? The graph shows that there is only one point of intersection. Therefore, the equation has exactly one real root. So, now the second part. The question asks you to prove that the root is between -2 and -1. Now from the graph, you can see that the root is somewhere here, right? So it looks like it's between -2 and -1. But how do we prove it? So by using intermediate value theorem. So first, to use intermediate value theorem, first you must change this equation. To fx equals 0. And then you let fx equal this. Right? You cannot use this. You must use fx equals 0. So you let fx equal this. Then you substitute -2 into f. So you will get -14. Then you substitute x equals -1. So you get 2. Now from here you can see that there is a change of sign from -2 to 1. So it means there is a root between -2 and 1. So you write a conclusion. So it says here, like here, since there is a change of sign between f-2 and f-1, and fx is continuous, therefore the root is between -2 and -1. Now let us look at second example. By sketching suitable graphs, find the number of real roots of the equation e power x minus 5x equals 2. Now this question just asks you to find the number of real roots, which means we draw the graphs and then we look for how many points of intersection. Now if you look at this equation, if you choose to draw this graph, it's going to be difficult to draw. So what do we do? I change the form of the equation, I rearrange it. I arrange it into this one. Now, then I just need to draw this graph, and then another graph which is a linear graph over this side. So these are the two graphs that you need to draw, which is much easier than drawing e power x minus 5x. So let's sketch the graph. Now the first graph, y equal e power x, is an exponential graph. Remember, you must label the important point. All these this point should be this one should be 1. You have to label it. And then the second graph, which is a straight line, you just need to plot 2 points and then connect the 2 points. Now you will get a graph here. Now can you see there are 2 points of intersection, 1 point here and 1 point here, right? So can make a conclusion. Now there are 2 intersections. Since there are 2 points of intersection, therefore e power x minus 5x equals to has 2 real roots. There are 2 real roots. Now let us look at the last example, right? Now, this question asks you to state the equation of asymptotes of this, and then you have to sketch the graph. Now, do you still remember how to find asymptote of a function? Now you can use limit, right? First, you can use this. You know, when you see that when x approaching 1, your y will approach negative infinity. And when your x approaches infinity, your y will approach 2. Which means the limit is 2. So based on this, you can make conclusion that your vertical asymptote is x equals 1. And your horizontal asymptote is y equals 2. Based on these two, you should be able to sketch the graph. Now first, let's draw the axis, and you draw the asymptote, label it. This will be 1. Here is 2. So this is x equals 1, this is y equals 2. Now based on this, you can plot a few points. Now you will see that when x approaching 1, when your x approaching 1, y will approach negative infinity. Means your graph will come from over here, and when it will go over here, right? When x equals 0, y is 1. That means this point is 1. So But over this side, when x is 2, you substitute into the equation, you will get y is 1. Y is 1. So from negative infinity, you go up, will be means you square would be something like this, right? So your graph should be like this, right? Now let us see the second part of the question. By sketching another graph on the same axis, find the number of real roots of equation this. Find the number of real roots of this equation. Now you don't need to draw all over again for this one, because the earlier part, the first graph has been drawn for you. That's why the question says by sketching another graph on the same axis. Means we are going to use back this graph. So to use back this graph, you must change this equation. You must change this equation into this form. Change it to match this one on one side. So what should we do? Now if you look at this equation, now I can bring this part over here, so you will get this. Then bring this over here and this over this side, so you get this. So can you see that this side it actually matches this one, the graph that you have drawn. So we need to draw another graph, which is this. So which means we have to draw y equal 3x. Now this is the another graph that we need to draw. Now it's a linear graph, a straight line, a very simple one. So this is the graph, y equal 3x. So the question says find the number of real roots. So you look for the intersection point. We see that there is only one intersection point here. So what is your conclusion? Yes, there is only one real root. There's only one real root. Right? Now, since the question does not ask us to prove that the root is between the two integers, so we don't need to use intermediate value theorem to prove it. But if the question asks us to prove the location of the root, then we have to use intermediate value theorem. If the question asks us to show that the root is between 0 and 1, then we have to find f0 and f1 to show that the root is between 0 and 1. Right? Now that's all for today. I hope you can understand my lesson. You can understand the lesson. So you have to try all the question in checkpoint 12.1. And if you encounter any problem, you can forward to your respective teachers and they will explain it to you. So that's all for today. Thank you for your attention and God bless you.